Hello, Steve Delamarter and Gary Jost here to explain the spreadsheet that is on this reports page, talking about identifying variance. This is the place in the process where we are preparing to turn text into numbers. Let's walk into it here. In this video, we want to cover what is in the file, how it was produced, what its value and place is among the THEOT scripts. And then out of this work, we've learned there's all kinds of other things you can do. So this other information or using scripts to do processes like this, there's great potential in this sort of thing. And we'll point out some of the things from our experience. So the file that you have downloaded or opened is structured in the following way. Just a regular Google spreadsheet. Column A gives the TVU number, text variation unit, which is a synonym for our work for column. Column number, 1,800 columns of text, line text in Hosea. And these correspond then to places in the text. Chapter 1, verse 1a, then column 1, column 2, column 3, so on and so forth. And then we ignore column C. Column D is the most important data that comes out of this spreadsheet. And it's what we'll focus on, but we'll also near the end talk about the information that's in column E. Dr. Jost, you wrote the scripts here. How does this all work?
Okay, thank you, Steve. So on the left here, we see what we refer to as the dots and bars file, and it's the file where we lined up, according to Ge'ez Root, the text of all the different manuscripts. In this first step, the THEOT computer program establishes a very simple typology for each column. Okay, it's not yet trying to identify what the word is in each column. Instead, it only establishes the possibilities for each column. If all the manuscripts have a word in a column, then the possibilities for this column are only 2 word, and every manuscript will eventually be assigned a 2 for this column. And you see this actually in the first column, okay? The exception is the 4th manuscript, where the square bracket indicates we don't know what the text is. You know, it's a page missing, pages damaged at that point. But all the other manuscripts do have a word. And so that's the situation where the only option is there's a word there. But if some columns have the word and others do not, then the possibilities for this column are 1, no word, or 2, word. Eventually, those with no word receive a 1, and those with a word will be assigned a 2. And so an example here is the second column, where, first of all, the 4th one has the square bracket, and so we don't know what is there. But then there are 2 manuscripts that don't have the word, all right? And so those will eventually get a 1, and then all of those that have the word will be assigned a 2. All right, there are a few exceptions to how this works. And so far, this typology is incomplete. There are reasons why some of the manuscripts cannot be assigned either a 1 or a 2 in a particular column, or places where the matter is complex. For instance, in some manuscripts, a manuscript is damaged or missing or obscured so that we simply cannot tell if there was a word present or absent. So it wouldn't be accurate to say that the scribe didn't put a word there. It's like we don't know what is there. Such locations are transcribed with square brackets and will eventually be assigned a 0. In the statistical comparison with other manuscripts, these zeros will add neither to the numerator nor to the denominator, which means essentially they're ignored in the calculations. Or in some places, a secondary hand has intervened and added a missing word that was not present in the original hand. Such words are transcribed with parentheses, and in this column, the manuscript is eventually assigned a 1 because the primary hand did not put a word there.
Excellent. Excellent. So further illustration here. Here's the same set of text, and you can see then the column numbers assigned to each of those aligned columns, and then the columns in the spreadsheet. And column A at line 3 is the first column, right? And it's made the decision that in this case, the possibilities are simply two. There's a word present because this one is ruled out. It's got brackets around it. And that means all the rest of them have exactly the same a word with the same root, and therefore the only possibility is going to be everybody's going to get a two. But in column 2, we can see it's a different story because of these two manuscripts that have a dot. And then column 3, there's only one manuscript that carries a particular reading, an idiosyncratic reading, by the way. And all the rest of them have no reading. And the same with the fourth. The fifth, there are two manuscripts that have a unique minority variant. And that also creates the possibility of one and two, one no word, two a word. And this continues on down to 7 again, where we arrive at a column where everybody has exactly the same, a word based on the same root. So from all of this, we're hoping several things are coming clear to you. Number one, the transcription of the manuscripts requires really exacting work in which not only the words and letters are transcribed correctly, but also all acts of scribal intervention or damage to the manuscripts are marked correctly. That's because we assign different numbers to these things as we quantize this and turn text into statistics, text into numbers. It won't be able to calculate things accurately or correctly unless we've done that work right. And then the computer is not going to correct wrong judgments made by humans. The same points are true of the aligning of the text into columns. That is also a step in which the crucial decisions are made about words with shared roots or not. And some of these are very subtle and are easy to miss. Once again, the computer will not correct wrong judgments of humans. Now, those 2 points speak to what we did in the project, but now we're hoping that it's also clear that this kind of strategy can help us go in lots of different directions. Dr. Jost?
Yeah, so this THEOT program can be used to compare not only variant readings, but also variants of spelling, okay? Variants of the use or not of the conjunction wawa. Sometimes words have that, sometimes they don't. Letters used to spell the words, as in the sound-alike letters, which refers to the standard normalization. Certain letters in later Ge'ez came to be pronounced the same, and so scribes sometimes substituted one for another, and also other possibilities. All right, here's a lot of information in front of you. The columns on the left is what Steve described just a bit ago, up through column D, where what we call the words profile match. Again, it's identifying what are the possibilities in this column, whether there's a word there or not. Another one that we experimented with is to be very precise and do an exact match, as we call it. This is seen in column E, where every single variation, whether it's a spelling variation, whether it's a different verb form, perfect or imperfect, whether it has a suffix like an object suffix, every single variation is taken into account and considered a different variant. All right. In column F is where I mentioned the wawa, whether it's present or not. And so whether a word starts with a wawa or does not, when it is the conjunction, it's considered the same variant. And so if we go then to, it's TVU 8, in column E, there are 6 variants. Again, to the exact letter, any single difference will cause it to be a different variant. But then whether there's a wawa there or not, in column F, it's considered the same variant. So variant 1 there is the same word with or without a wawa, and the second variant is similar, with or without a wawa. And so, and I won't go into details on these other ones. We did some experimentation with those. And each of those can be used to tell us different things about the text and its variants. Ultimately, we decided for our purposes that we would use this matter of whether there's a word there or not, what you see in column D, because that gives us the best information for studying the textual history. And so we'll point out this step is based on the one before, as in the computer script based on the one before. And then this script that we've been describing forms the basis for the next script in the process.
And all that goes to establish that this workflow involves not just one step. The creation of data involves multiple steps of working with numbers, creating things. But then there are several further steps that involve filtering, processing, sorting data that helps us extract or see aspects, dimensions of the text and its textual history that weren't possible unless we do this sort of filtering and sorting. Thank you for your time.
Thank you.